All right, calculus in the first derivative test, number 26. We're looking for increasing and decreasing intervals. We're looking for critical values. Critical values are where the slope goes to zero or the function is non-differentiable. So we're looking for any issues here, which I don't see. So let's start by taking the first derivative, which is f prime at x. And we know using the sum or difference rule that it's 4x cubed minus 32. And remember, to find a critical value, we want that f prime at x to equal 0. So we'll go ahead and set that equal to 0. Start to solve, we'll get 4x cubed is equal to 32. 32 divided by 4 is 8. So we have x cubed is equal to 8. Cube root of each side gives us x is equal to 2. Isn't it? So I think that's where we end up here. This thing doesn't leave us very many intervals. Let's take a look really quickly at what this graph, not what the graph looks like, but what this thing looks like on the Cartesian plane. Here's the Cartesian plane, and our only critical value is at x is equal to 2. So I am going to show this to help me find my interval that x is equal. Let this be the line x is equal to 2. And what I know that somewhere on this line the slope goes to 0 here. Somewhere on this line the slope goes to 0. So it only leaves us actually with two intervals, doesn't it? It leaves us with the interval to the left of this. Right? So as I'm looking, I want all values to the left of that, and I want all values to the right. So it just gives us two intervals. So I'm going to set up my table, set it up with intervals, test value, f prime at that test value. So I want the sign of that, a little bit backwards, I want the sign of that, and then I want to come up with some conclusion here. Oops. Conclusion, right? So the intervals are pretty easy. We have x is less than 2 but greater than negative infinity. That's this arrow right here. And the second interval is the one that goes the other way, which is x is greater than 2 but less than positive infinity. Choose some test values here. X is less than 2. I guess I'll choose f prime at 0. And f prime at 0 is what? Is negative 32. So it's less than 0. So it's decreasing, isn't it? So these are the conclusions that we're asked to find. So it's decreasing everywhere on this interval. And here we need a number that's greater than 2, maybe, I don't know, f prime at 3, f prime at 3. I'm going to plug that into this equation, and f prime at 3 is going to be a positive number, isn't it? So that would give us that this would be increasing there, won't it? So f prime at 3 is greater than 0, and therefore we have an increasing interval there. All right? And that's what we're asked to do, find those intervals where we have increasing and decreasing. So we know that everywhere from here to here, I don't know where it's going from. I know the slope goes to 0 somewhere, but this thing is decreasing here, so maybe like that, I don't know, and then increasing on the other side of it. So I hope this has been really helpful. If you haven't already subscribed, please do, and your comments are always welcome. Thanks.